Hello, everyone. We're gonna wait a few more minutes to see if some more people join, and in about 1-2 minutes, we'll start with the webinar. Thank you for being here. Okay, so hello everyone, and welcome to this RatedPower webinar, Substation Engineering A to C, the importance of the interconnection facility solution when designing a PV plant. So for today, you have myself, Gabriel. I am account executive for the North American market here at RatedPower. I've been in RatedPower for the last 3 years, growing our pipeline in the US and trying to adapt our product to that market. And of course, we have, most importantly, Sukaina Germuni. She goes by Suki here. She is our product manager of Interconnection at RatedPower. So she's the mastermind behind all of our developments related to interconnection, so Substation, Gentai, and she's a PV engineer expert, and she's the one managing currently our product team focusing on these interconnection aspects. So for today, this webinar will last for about 45 minutes. At the end, we will reserve around 10-15 minutes for any questions that you have. So if you have any questions at any time, please write them in the questions chat box that you have available, and we'll try to answer most of them, or the most that we can at the end of the call of the webinar. And then if there's any pending questions, we'll try to get back to you by email, so you get those. So for today, first, we will start with the importance of the interconnection design. We'll discuss why the designing of the interconnection facilities is important, the different types of interconnection facilities there are, and the different components that are within them. Then we will talk about the main criteria for a good solution when designing these type of interconnection facilities. Then we will show you a little bit about pvDesign, so how at RatedPower we are helping automate the basic engineering of these interconnection facilities. We will review as well the documentation that pvDesign provides when starting the design of interconnection facilities with pvDesign. We will also discuss about our future developments, so what's coming next into RatedPower with regards to interconnection, not only Substation, but also the Gentai or the overhead line design. That is something we launched recently and that we are putting a lot of effort in. Of course, as I mentioned at the end, we'll leave a few minutes for a Q&A session. So I thank you all for being here, and I'll leave it to the expert, Suki, so the floor is yours.
Thank you so much, Gabriel, and thank you all for joining us today. So as Gabriel mentioned, we're going to dive deep into the substation or the interconnection facility with its types and how to have an automatic solution using our software pvDesign. But first, I'd like just to mention quickly like the importance of the interconnection facility design. As you might know, all of you, that with the expansion of the clean energy generation, and more specifically solar and PV, also the transmission capacity has seen a rapid growth and expansion. And that gave kind of a responsibility to solar developers to start designing the interconnection facility instead of only utilities in most cases. And that's why we think it's really important to have a good solution, good design, and that's how we thought of including this part of calculations or designs into pvDesign to give our users the possibility to have their most important documentation, basic engineering calculations for their interconnection applications. So basically, what we have, or the substations that are mostly used, are air insulated substations. Sorry, those substations are step-up substations with voltages that are different from the input to the output of the substation. Of course, the substation as a whole, or interconnection, is kind of an interface in the power network between the feeders, the MV lines, and the transmission or the distribution line. And for the step-up substation, we have different types that we design. We have a line-to-transformer substation, we have a single busbar, double busbar substation. Why did we pick these three main ones? Simply because we noticed that are the most used in the industry, and also the ones that cost less compared to other substations, step-up substations. So the line-to-transformer is a simple substation. It doesn't have a bus bar, so it has only one input bay with one power transformer and then one output bay. So it's the most simplified, I would say, configuration of a substation. Of course, one of the disadvantages is not having a secured supply, especially during maintenance, for example. So that's the advantage, the main advantage of the line to transformer, but it costs less. Then we have the single bus bar that gives us a more flexible bay configuration with the bus bar, of course, but also it lacks a little bit the security of supply. And then comes the double bus bar, which is used mainly for big plants with big capacity. But here, since it has two bus bars, it gives security to supply, definitely, rather than the single bus bar. So those are the type of substations, step-up substations, but those are not the only interconnection facilities that we can have. We can have also switching and breaking stations, which are some switch gears that we actually design in the software as well. So we have that. They're usually used for small plants to connect directly the MV lines to the distribution line. Not only for small sites, but also small capacity sites, but also sites that are close to residential area or commercial area. And of course, when we say designing a substation or interconnection facility, like the main parameters that we consider are the voltage level, the MV voltage level, and the HV level, both levels. And of course, beside that, we consider the MV lines capacity, the plant's capacity generated. We consider the short circuit current and also the environmental conditions to calculate the installation coordination and later the electrical clearances and so on. So those are like the main parameters to consider. And in pvDesign, we do take that into consideration in our calculation. And that is why we consider our calculation very not detailed, but at least it gives the most important things for basic engineering, considering all the important parameters of the engineering calculation. So moving to the selection of the interconnection facility. So as we said, we have switching and breaking station, we have the step-up substation, and then in the step-up substation, we have different types. So of course, there are a lot of criteria that we consider, electrical criteria like the short circuit current, the short circuit impedance of the transformer, the total current of the plant, and so on. Of course, the capacity of the cables as well, in order to choose one arrangement over the other. And of course, we have electrical criteria to calculate the number of bays, the number of transformers needed, the number of output bays needed. And among the calculations that we do in the software are the short circuit current. So we run a short circuit calculation and in the MV side and the HV side. We also do an insulation coordination calculation by which we get the clearances. So we calculate all the overvoltages, the slow front, the fast front, the temporary overvoltage or the power frequency, and then we give the clearances after that, the electrical clearances and also the safety distances. And all of these calculations are made upon the choice of the sender that the user can choose in the interface that we're going to see in a few seconds. The two standards that we have are IEC and IEEE. So IEC for the European mostly and European countries, and for the IEEE for the North American countries. And yeah, apart from that, we calculate or size the bus bars for the substations with bus bars, single bus bar and double bus bar. Based on several parameters, we give the dimensions and the electrical characteristics of the bus bar. And of course, we do the sizing of the electrical devices of the substation, all the protective devices, the surge arrestor, disconnector, circuit breaker, the current and voltage transformers as well, and obviously the power transformer with all the necessary details in its sizing for its sizing. So the best thing to do right now is to go through pvDesign and show you exactly how to design a substation. And not only substation, but also switching breaking station in the software. And from there, as Gabriel mentioned earlier, we can go through the documentation, explain to you the different output that we generate. So the first thing that you have to do in the software, so as you can see, to some of you who are not familiar with pvDesign, we have here several sections. From importing the location of the plant to choosing the equipment, the power requirements, the topography restrictions. Then you have the grid point where we design the substation and also the overhead line that we mentioned earlier. That is also something that we recently launched, and we're gonna probably talk about it more at the end of this presentation. Then also the electrical part, the batteries in case of batteries, and the energy calculation, the losses, and the cost part. So today, of course, we are focusing more on the grid points. And the first thing that you need to do is to create a site either by importing it as a KML or create your own site directly from the software by clicking on this one. So here you can directly click on Polygon and create your polygons, and one of them is the substation. And same thing for uploading your own KML file. So if you click on show details, you'll be able to see the element or the polygons, and one of them is the substation. And of course, within the substation, you need to have like a connection point for the NV lines that we call NV, the NV point within the substation. But that's mainly the first thing that you need to do to design your substation in the software, to have this ST polygon within the KML file within your site definition. And from there, if you go to the grid point, you'll have these different sections. The first one, as I was mentioning, is the electrical sizing standard. So you have the IEC and IEEE, as I was mentioning. And then in the connection type, you will have the different interconnection facilities with the voltages. So obviously, as you can see here, we have the substation. So you can choose the substation and select it, and the software will automatically give you this solution, either a line to transformer, a single bus bar, or a double bus bar. And then we have a switching and breaking station that you can select as well. Also, talking about the step-up substation.
Suki, I have one question there. So, what would be the criteria used when choosing switching and breaking a station or a substation?
Yeah, good question, Gabriel. Because as you can see in this case, the switching and breaking station it's kind of disabled. You cannot select it. And that is because we have some criteria to enable the switching breaking station. The first one, we need to have a capacity less than 60 megawatt, and also a total current less than 1,250 amperes. Those criteria are mainly to meet like the realistic scenarios to use the switching and breaking stations, since it's used for small sites where there's no need to step up the voltage, there's no power transformer, it's just a switchgear. So as you can see here, since we have a higher capacity, we're not able to select it. But I'm going to show you in a few seconds how to do it. But those are the main criteria for select switching and breaking station in the software. So also I was saying that for the substation, we have, as we have different types, and we knew that it's hard to give an automatic solution, probably because the utilities are responsible of kind of saying what type of arrangement is needed. So that's why we decided to include this manual arrangement that the user can enable. And in here they have option between single bus bar and double bus bar. And in this case, the software will calculate the substation based on the arrangement selected. So you have this option as well. And once you select, of course, the substation or either the manual or the automatic solution, you have to introduce the HV level and the MV level. So as you can see here, we give you a recommendation on MV and HV levels, but it's modifiable. It's something that you can modify. Going back to the switching and breaking station, so simply here, if we go to layouts in the power requirements, and if we decide to choose a specific capacity where we're gonna choose the number of inverters that we want, let's say 15 inverter with a DC-AC ratio of 1.2, if we refresh, we're probably gonna get a lower power than 60 megawatt, and definitely a lower total current. So if we go here, as you can see, okay, it's not enabled, so probably the current is higher. So let's see if we bring the voltage to 32. Yeah, now we are able to enable it. Also, you have this info here that says when it's disabled, it says that those are the criteria that we'll consider. So now you can just select the switching and breaking station, and since there is no power transformer to step up the voltage, then all what you need is to introduce the MV level directly. So now if we go back to the substation, we have this section regarding losses, and in here you can introduce the losses of the substation, the iron loss and the copper loss, and they are considered in the energy production. And also, if case you have any grid requirements, you have this possibility to size using the factor requirement, the power factor, the cosine of phi. So if you enable it, you have two options, either to measure or have the point of measurement before the power transformer or after the power transformer, meaning to consider the power transformer or not. Here you can introduce the power factor required, and will give you or calculate automatically the power factor at the output of the inverters. And of course, this is considered in the energy calculation, energy production at the end. Another thing that I didn't mention earlier and I want to talk about is the type of the power transformers themselves. First, in our design, or to have a good solution, we try to kind of balance the capacities of the MV lines between the base in a way to have the same capacity, more or less, of the power transformers in all the bays, in case of having many bays, and also having the same short circuit impedance of the power transformers. And also beside that, we have automatically, we calculate either a 2-winding transformer or a 3-winding transformer. So that's something that we do automatically. We try to give you, based on a cost-effective consideration, based on cost, basically, we give you one or the other, either a 2-winding power transformer or a 3-winding power transformer. Here, for more details regarding the criteria, basically what we consider is the size or the capacity of the plant. So if it's a big plant, we have, if I'm not wrong, a criteria of 10,000 amperes. So it's higher than that, we automatically give you a 3-winding transformer, because simply we got more feedback and insights from experts in the field saying that for huge or big, very big plants, usually 3-winding transformer costs less because you have less number of input bays, so that means less devices, less protective devices, less electrical devices to buy, so it costs less, and that's why we do this automatically. And of course, if the site is smaller, we again automatically give you a solution of a 2-winding power transformer. This is about the input that you need to introduce. So the inputs are not a lot because, as I mentioned before, it's kind of an automated version or calculation of the substation. But later in this presentation, we're going to talk more about the future improvements, and we can discuss that further. Also here, I just want to highlight a small thing, small detail. As you can see here, we have this overhead line going from the substation. So as I mentioned earlier, we do have design of the overhead line, basic engineering of the OHL, transmission or distribution lines. So it is something that is considered also automatically calculated, since the user needs only to draw the path of the overhead line starting from the plant substation till another point, which should be the utility substation, and then we do the rest of the calculation. And also we can discuss further about the overhead line and the OHL at the end of the presentation. So once you have your substation or switching and breaking station selected, all you have to do is generate the design. And once you generate it, you will have, we can go directly to one of the generated designs. So you will have your design, and in the results page, you will have the documentation generated. So here we can go through this documentation. We have the main ones are the interconnection facility report. So either switching and breaking station or substation, you can have a complete report with the calculation, with the results of the calculation, the sizing of the devices, and so on. We're going to check it out right now. And also we have the SLD and the layout. And of course, the elements of the substation are also depicted in the bill of quantities. So in the bill of materials, you will find the substation sheet with all the quantities of all the elements and the units and their respective units. So here you can download them in both format, like editable and non-editable format. So all you have to do is click on one of them and click on download, then you have it downloaded. Here I have them, I think, all downloaded, just not to waste time. So we can go through that quickly. Let's start by the report. So for the report here, we have several sections. We have an introduction, a description regarding the site, topography, a description of the substation, the general considerations of the substation, and then description of the high voltage system, for the equipment of the high voltage system. Then each part of the substation, from the transformer bay, the output bay, the busbar level, the power transformer level, and then the medium voltage system. So everything is very detailed with the characteristics of each system and each element. So we can go through it. So as you can see here, we have description of the project itself, with of course the circuit arrangement. So in this case, we got a single bus bar with 2 power transformers. We have here the capacity of the substation, the high voltage level, the medium voltage level, and so on. Then we have a description of the location of the site and of the substation, of course. Then we have the topography, because we try to do an earthwork, perform an earthwork to the substation. So that's why you have this part in here, giving you the earthwork results, just to flatten the area of the substation. And then we have this section regarding the description of the substation. You have once again a table with the summary of the substation. We have another table showing the characteristics of the power transformers that we have. In this case, we have 2. You have the voltage ratio. We have the rated power of each one of the transformers, the short circuit impedance, and the vector group of the power transformer. So again, here you have the medium voltage system characteristics. So we have the switchgear or the cubicles. As you can see, we have the number of cubicles of the NV switchgear. We have the voltages, the short circuit level, and the insulation material. So basically all the details regarding the NV switchgear. Then we have the general considerations of the substation. As I mentioned before, we consider the environmental conditions. So you can see here the altitude, the pollution level, the temperatures, the air pressure, and so on. All of that is considered in the calculation. Then you have here the short circuit current levels for both voltages in the MV and HV side. The insulation coordination, so as you can see here, you have the lightning impulse with sent voltage, the short duration power frequency voltage for the phase to earth and phase to phase. And from there, we get the minimum safety distances. You have some illustrations to show you exactly the safety distances that we consider and the results, as you can see here. The different heights to be respected by the equipment, distances between equipment, and so on. And all of these distances and clearances, you will find them summarized in this 4 tables. Then you will have the HV system description. You have here a description of each of the equipment in the HV system, the instrument transformers, the power transformer, the grounding devices, and so on. And then you will have the number of each corresponding number of each element in the transformer bay, the ones in the output circuit bay, in the busbar level. So in each part of the substation, you will have the corresponding number of devices. And then you will have a section to detail each level. So here we have the transformer bay. So you have the disconnectors, the circuit breakers with the size and the rating of each element. You'll find here the rated short circuit with sent current, the normal current, the rated normal current, the voltages, the frequency, and so on. And that's for all the other equipment that we have in the transformer bay. Then you have the output circuit bay, so it's the same thing. We have descriptions for each device of the output bay. Then we have the busbar level. So here, as I mentioned, as we designed the busbar, you will find the parameters or characteristics of the busbar. You will find also the post insulators, the voltage transformer in the busbar, as you can see with their ratings. Then we have the power transformer level, once again with the table with the power transformers, with the earthing devices or the grounding devices of the power transformer, the surge arrestor. And I think finally the medium voltage system with more details regarding the switchgear with the cubicles. So here you go, you find all the cubicles, the incoming line cubicle, the outgoing lines, the metering cubicle, the auxiliary cubicles. You'll find all of them with descriptions in the tables. And of course, we have also the cables that connect the cubicles to the power transformer. You'll find here the section of the cable, the material, and the installation material, and installation type. And that is about the design report. And as I mentioned, we have also an SLD, an electrical SLD that you'll be able to find here. So in the same design as you can see, we have a single bus bar. So we have here, let me zoom in a little bit. You have here the basically the NV lines coming from the plant, sorry, and then you have the cubicles, as you can see, with the ratings that were calculated, the outgoing cubicle, the cables, and then here you have the power transformer. So you have both power transformers with their impedances, their capacities, the voltages, surge arresters, and then you have the outgoing bay after the bus bar, which also has here its rating. And then, as I mentioned, here you have the outgoing bay with all the devices up to the point, the connection to the grid. And then we have here some notes in the same SLD PDF. So you find here description of the substation, the characteristics of the HV and the MV side of the substation. So again, like a summary of the substation characteristics. And of course, a legend to show you like each device or each symbol, what it means. These devices and these SLDs also will change depending on the standard that you choose. Either IEC or IEEE will have the corresponding symbols to each standard. And finally, we have the layout, which is a file that gives you the profile and top view of the substation. As you can see here, we give you an approximate area of the substation. You have here the control building. Then you have both of our power transformers for this design. Once again, with the capacity of the power transformers, here you can see clearly the clearances, the distance between the devices. Then you have here the bus bar, the span of each bus bar, and the distance between the bars, and also the outgoing bay with all the devices. So this is the top view, and also we have the profile view. So it's going to be the same thing. You're going to have illustration of or layout of the substation up to the gateway to the point to the transmission line. And the last document where we depict, we show more details regarding the substation is the bill of quantities, as I mentioned before. And in here, you will find the quantities. So when you open the bill of material, you will find several sheets regarding different parts of the design. And here you'll find a simple busbar substation that we got from our design. And as you can see, once again, you'll find it splitted into categories or sections regarding each system. So you have the power transformer system. With the power transformer here, you have the toggle, you have the HV winding earth-in, the MV winding earth-in, the surge arrestor, the MV cable length. Also the HV system, again, pretty detailed with the transformer bay, the bus bar, and all of the quantities. And also we have here the civil work. So you'll find some, the volume, the cut and fill volume of the earthworks done to the substation area, the control room building area, the security and control. So just some details and some other miscellaneous elements. So this is when it comes to the substation, and as we mentioned, since the software also designed switching and breaking station, here I also have some documents regarding the switching and breaking station, just to give you an idea what we did. So for the report, it's a shorter report since we don't have a lot of elements regarding the switching and breaking station, but once again, here you have a description of the site, description of the characteristics of the switching and breaking station. So as you can see here. So here we have a description of the station with the number of each cubicle. And then the general considerations, once again, with the short circuit current calculation, the insulation coordination, of course. And then each, here you will define or we explain more in detail about the feeder function of the cubicle, feeder cubicle, then the circuit breaker protection function. So basically all the cubicles that we have in switching and breaking station with their functions, we explain them here further with the rating of each feeder or cubicle, as you can see. So here we have the fuse protection function with an illustration, and then the rated current of the disconnector and the fuses. And also we have the metering function, of course, within the switching and breaking station, and finally the cables. So it's a very short report that summarizes the switching and breaking station, and same thing for the other documents. We have an SLD representing the switching and breaking station, as you can see, with the NV lines coming from the plant. Then you have here all the feeders, and you have the rating of each element of the switch disconnector. We have the current transformer, the voltage transformer, the fuse, and their corresponding ratings. And of course, we have here a layout. Same way we have for the substation, we have a profile view and top view with some details, and also like the dimensions of each feeder, each cubicle, and also the characteristics, the corresponding characteristics in legend, notes and legend. And finally, same thing for the VOQ. You're gonna have here a short list of materials, of bill of materials in the bill of quantity, depicting or here switch and breaking station. You have here each cubicle and the unit, the total unit of the number of each device within the switch and breaking station, and finally the civil work, the earthworks volume that we perform. So basically those are like the main things or output that we generate using pvDesign. So apart from that, I would like to go further and share about you more or talk more about the future developments that we have in the short term. It is true that we do know that it is an automated solution for the substation and also for the overhead line, since as you can see, you only have the possibility to choose the arrangement, introduce the voltage levels for the substation, and of course create the polygon, and there is not more input that the user can give in the software. And that is why we decided to work on customization of the substation. So in the near future, hopefully by the end of this year, we'll be able to give the users more input regarding the substation, such as selecting the number of power transformers or selecting the capacity they want for the transformer, choosing the type of the power transformer, either two winding or three winding transformer, also introducing the short circuit impedance of the transformer, selecting or deciding on the number of the output bay. So those are some of the input that we would like to introduce very soon for in the software for the user to manually design or have more flexibility in the design of the substation. And same thing for the overhead line. As I mentioned, we only have, like right now in the interface, the user, all they have to do is to draw the path of the overhead line. But in the near future as well, we'd like to have more input, like choosing the conductors, choosing the earth wires, choosing the type or the shape of the towers, supports of the overhead line. So that's also another thing that we would like to do. And of course, we're currently doing a lot of discoveries regarding both subjects, either substation or overhead line, to give more flexibility to the user, because at the end, that's what we would like to have. And that's what we would like to give for our users, is to give them more flexibility, to be able for them to design based on the requirements of the location of their projects, based on the utilities, based on the country. So that's why we opt, or our objective is to give this flexibility. And that also leads me to a small idea that I would like to share, which is the feedback of the users. It's very, very important for us, because most of our development, we base them on the feedback of our users, and we take them into consideration when we plan for improvements. So we always encourage you to send us feedback. Either you are a user, if you're not a user and you would like to see something in our product, feel free to contact us anytime and give us ideas, feedback, things that you will need in your day-to-day work to help you in your needs. So, Gabriel.
Yeah, no, thank you, Suki. I'll let you breathe a little bit. So yeah, I think we have a few questions here. I'll start with a few that I can respond on, so you can catch your breath, and then I'll continue with a few that have come for you. So yeah, is this going to be recorded? Yes, all you will receive the recording probably tomorrow through email. And then for a free trial, if you're interested, you can reach us out through our website, RatedPower.com, and request a demo through there. Then I have a few questions for you, Suki. So first one, expanding on the switch chart versus substation, beyond the capacity specifications, what are other typical reasons to have one over the other, or in some cases even both?
Honestly, like the main criteria is the capacity. So what we received from people in the field, that usually the switching and breaking station is used for really small sites, where there's no need to, the sites that are close to residential areas, where there is no need to step up the voltage, so there's no need to have a step up substation. And that's why we decided to have this criteria to limit it in this way, in terms of capacity and also in terms of maximum total current. But of course, I encourage you, if you have any other thoughts from your experience, just to share that with us, and for us to consider if there are any other considerations that we should pay attention to. Yeah.
Great. Another question for you. So the high voltage level, it's limited at 400 kV, and the Brazilian market sometimes uses 500, even 525 kV. are you planning on maybe upgrading or making bigger this limitation?
Yeah, actually, we received this feedback many times, and we do understand that a lot of our clients and users are in locations or in countries, their projects are in countries where the voltage requirements is higher than what we give. 400 kilovolt for them is very limited. So it is something that we have, of course, in mind, and we're gonna consider it definitely for our improvements. The only thing that we might need is to reach out to experts to understand exactly or better the needs, but it's definitely part of our, it's an idea that we have for the roadmap for sure.
Great. Then we have another one here. Can these layout files be exported as CAD or shape files? So I guess they're referring to the different drawings, so SLDs and layouts, well, the layouts as well. I think they can be, right?
Yeah, they can be exported as CAD, like in the software. Let me show you quickly. Here, so in the documentation, when you want to download a certain document, so here for the drawings, SLD and layout, you have PDF and you have DXF. So you can just select the DXF. You have them. You will have the DXF file or the CAD file. However, you said CAD and shape files, right?
Yeah, shape files.
Yeah, for the shape files, we do not have that format, but we can export that. But for the CAD, it is a possibility.
Okay, another question. Does the software specify anything about loaded, unloaded step-tap chargers in the transformer?
No, it's not something that we currently have, but we would like to give more detail and go deeper in the calculation, and especially for the power transformers. So it's something that we have in mind as well, but currently we do not have that.
Okay, and another one. What is the inverter level voltage?
The inverter level voltage?
Yes.
I didn't get the question. I don't know if the person who asked can elaborate.
I guess, what is the voltage level of the inverter?
I mean, if you are asking about the NV level that we consider, it is the NV level that the level of the power stations of the inverters, but it's something that you can modify in the software. You have the NV input that you can introduce, but here I'm not sure if this is exactly the question or if it's something. If something different, please just elaborate. But yeah, generally the NV level, it is the level of the power stations that you can define on the software. And for the HV level, of course, it's something or usually a requirements from the utility that also you can define directly in the software from the interface.
Okay, and I believe this is the last question. So, does the calculation for the design of the substation take into consideration the environmental conditions of the site?
Yes, we do. I think I mentioned it briefly, but actually we do. We take into consideration the temperatures from the meteorological data that you introduce. So in the software, you can introduce your own meteorological data, and also we have databases that you can select regarding the meteorological data, and also other things like the wind speed. We consider the pollution level. We consider the elevation, the altitude. Taken as well from the data that the user introduces in the site section. So yeah, we definitely consider the environmental conditions because we think that they're very, very important and crucial in defining or calculating the installation coordination, and hence the clearances, electrical clearances, and the safety distances.
Okay, so yeah, I think that's all we got for today. So, well, if anybody had any pending questions willing to ask, you can reach us through email, through our website. Happy to arrange a call with you to further discuss any of the topics that you see so here today. As Suki mentioned, we are very open to all of your feedback and to having discussions on any of the features of the software, and specifically today on any of the interconnection aspects of the tool. Any feedback is more than welcome. In the end, we're trying to improve pvDesign on a daily basis, and of course, no one knows the market better than the one that yourselves that are the one working on it every day. So happy to arrange a call with anyone that is interested to further discuss any of the topics today. So, well, thank you everyone for being here and for keeping up with us today and paying attention to our webinar. And of course, thank you, Suki, as well, for giving this lesson to all of us. That for me, it has been pretty enlightening. So thank you very much.
Thank you. Thank you all.